So in this video, we will talk about reflection about the x-axis and vertical stretching and shrinking of graphs. And what causes that is the number in front of our function, the one that's being multiplied to it. So let's look at the minus first. So here's our parabola, and right now we have a positive in front. If I change that to a negative, you can see it now goes down. Doesn't matter what the function is, it causes it to go down. See? All the graphs now go through that point that is down. It's the 1 right here. And so the way you can kind of think of it, again, we have that slope. And so instead of going up 1 over 1, we go down 1 over 1. And there is our graph. But what it's doing is they are normally positive. And so if I plugged in 1, I would get 1, and that turns it into a negative. So it's turning in all the positive values negative. And if we have a cubic, it's turning all the positive and negative, and then all the negative positive. So watch that one. See? So there's our positive 1. There is our negative 1. Positive 1. Negative 1. That's 2. There we go. But you can see the positives turn negative. Okay, so that is what this does. That's why they say it's a reflection about the x-axis. So if we have this, let's try that again. We have, let's try one more time. We have this. Our normal absolute value would look like this. But what we're going to do now is turn everything negative. So our positives will go negative and negative. And so it turns into this V shape that is reflected about the x-axis. Everything has been reflected. See? But it just really means instead of going up, we go down. And so this would just be a downward parabola because of the negative. And then this would be our cubic. And so to graph these, if you notice we have that pot 1, 0, and then that 1 in front, we go down 1 over 1. So it's down 1 over 1. Down 1 over 1. So you do the same thing here. It's down 1 over 1. So instead of graphing it up, you graph it down. And then the cubic goes that way. And so it's that down 1 over 1. And so then it would be up 1 over 1 for the cube. But everything is reflected. The cube normally looks like this. And the parabola looks like that. So what's happening to the graph when you put a negative? It reflects about the x-axis. That's it. Put a negative in front, it reflects about the x. But we're going to make this a lot quicker now. So we're going to do vertical stretching and shrinking of graphs. So let's look at that again. We're going to just pay attention to the absolute value and the parabola because they look really good when we do this. So let's click on the parabola. Let's look at our a. So right now that's my a of 1, that's my a of 2, a of 3, a of 5. So if you notice, if I put a 5 here, the number as it gets bigger, it is vertically stretching the function. It's like something's grabbing it from the top and pulling it up. See that? So if the number is bigger than 1, it gets stretched. So you can see there's our 1, right? Come on, 1. And then it gets vertically stretched. But again, you can graph these very quickly. If you remember, that's our 0, 0 for our shift. And then that 1 in front is just how much we go up and over. So you think of it like a slope. It's not a slope, but it's good for 1 point. So it's 2, we go up 2 over 1. It's 3, we go up 3 over 1, and so on. And if I change this step and get rid of that, you can see that no matter what the number is, it is that number. See? So as we go up. And so when we get less than 1, that's when they say it's vertically shrunk or compressed. You can see it's getting thicker. So right now it's getting stretched up. And now if we go back to 1, come on, back to 1. Just make it 1. Now if I bring it down, you can see it looks like something pushed it down. So it's compressed. So when we have a number that is bigger than 1, so our a, we're going to call this a right in front. If our a, absolute value of a, is greater than 1, it is stretched. So it's going to be a lot narrower. It's going to be very stretched. And if our a is less than 1, it's going to be shrunk. They will also say compressed. So it's going to look a lot wider than our normal parabola or any function. It doesn't matter what you use, it'll work the same way. So if we go in and put an absolute value and do that same idea, look, it looks like they're stretching and someone's pulling it, and then it's compressing it. But you can also think about it this way now. If you know what that number is, if it's 0.5, we go up 0.5 and over 1. Then if it's negative, you do the same thing. See, it's negative 2.4. From that point, you go down 2.4 and over 1. Now we're going to be sticking with 1 and fractions for each of these. Come on, step. There. So it just makes it look a lot nicer. And so if we have a negative 4, it's down 4 over 1. And then you just graph any function you want through that. But that is it. That is how we stretch it. So if you have a 2x, we know already that these are all 0, 0 because there is no shifting. So we're going to put a dot at 0, 0, 0, 0, 0, 0. And then you just use that number in front. So you want to write a is 2. So if a is 2, we're going to go up to over 1 and put a dot. And then you're just going to graph the function that goes through it, because this is vertically stretched by a factor of 2. The next one is 3, so we go up 3 over 1, put a dot, and then you graph the parabola. So you can see it's stretched. It's a lot narrower than our normal parabola would look. All right, so if it's 0.5, you would think, oh, that's 1/2. And so you go up 1 over 2. No, this is only good for 1 point. So you have to zoom in, and we go up 1/2 and over 1. So it's right there. That's our point. Why didn't it graph in red? I don't know. But it's the half mark. We're actually at the halfway mark. And then you draw the radical. So you can see it's been compressed. It's been pushed down. And so negative 1/3, you think, oh, it's horrible. But no, you just go down 1/3. So our first point, this dot looks really large now, right there. It's down 1/3 over 1, right there. So it's at that 1 mark, but it's at a negative 1/3. So whatever number they give you, that's how far you're going to go up or down, and then over 1. So it's going to be negative 1/3 over 1. 0.5 over 1, 3 over 1. So whatever your a is, that's how you want to think of it. That's your point. And then you just draw whatever it is. So this is a cube. Cubes have that upward parabola this way, downward parabola this way when it's negative. So from that point, it's going to go down, and then the other way, it's the same idea. It'd be up 1/3, so it's at the 3rd point there, and then that way. So it's compressed version of it. All right, so that is how you use the number in front. So the negative will reflect it, and we'll put all this together in the next video.